Hello everyone, this is actually the last part of the chapter on energy work power. This is the part on 6.3, which is power. The reason why I'm recording this video is because we don't really have time to go through the part on power in our normal lesson. So you have to view this video and to complete the worksheets that are given to you. So in this video, I use the Marshall Cavendish slides because you'll be able to write down all the blanks that are missing from your own slides. Alright, in addition to this, there's also additional pages in the presentation. When I come to these additional pages or slides, I will inform you and you'll need to pause the video to record down any information that is necessary. So first of all, let's look at the learning outcome. So at the end of this session, you should be able to state and use the formula of power, which is equal to work done over time taken to solve problems. So first of all, let's recall what we have learned in the previous parts. We learned that energy is defined as the capacity to do work. We also learned that work is the product of force and the distance moved in the direction of the force. So what's the relationship between power and energy? And what is the relationship between power and work done? So let's look at the definition of power. The definition of power is that it is defined as the rate of work done or the rate of energy conversion. All right, so it's a rate, is how fast work is done, how fast energy is converted. So here are two formulas for power. The first formula is power is equal to work divided by time. The second formula is power equal to energy divided by time. So in short, okay, these are the information about what does W stand for and E stand for. P is power, W is work done in joules, E is energy in joules, and T is time in second. Do take note that all the units has to be in SI units. Alright, like time has to be in seconds, joules has to be in joules and not kilojoules or megajoules. Alright, so are there any other formulas for power? Yes, in fact, power, there are 4 formulas that you should know about. These are the first 2 formulas. The next slide is not in your slides, so you need to copy the next slide. So the other 2 formulas are power is equal to force times distance divided by time, and power is also equal to force times velocity. So again, look at what does all these symbol represent. P is power, force is F, which is the force applied in Newton. D is the distance moved in the direction of the force in meters. T is the time taken in seconds, and V is the velocity in meter per second. So I'm going to explain to you how these 2 formulas derive from the previous 2 formulas. Alright. So as you know, that's power. Okay, get my pen. As we know that power is equal to work done over time, we know that work done is equal to the force applied multiplied by the distance moved in the direction of the force. If you put these 2 together, you realize that you arrive at this formula, because this work done is equal to the force times distance. So in other words, you combine them together, you get power equal to F times D over T. That's how you arrive at this formula. So it's actually simply work done divided by time, but breaking down into its what does work done represent. So how about the next formula, which is force times velocity, which looks very strange. Okay, it's actually derived from this formula here. Okay, that means this formula at below is derived from the formula above. So how do you derive it? Okay, look at this formula. You realize that actually I can, okay, let us move to here. We can actually write power as force multiplied by distance over time. All right. So, but you realize that if you write like that, you can actually factorize the distance over time aside, and you will actually get velocity, because velocity is distance divided by time. So power is equal to F times V. Right, that's how you arrive at velocity. Okay, so let's move on. So what is power? What are the units of power? The power unit is watts, or W in symbol form. So 1 watt is defined as the rate of work done, or energy conversion of 1 joule per second. All right. So that means that if you have 1 joule of energy and you convert it in 1 second, you produce 1 watt. So there are actually another unit for power, which is joules per second. So you can either write power as watts or joules per second. So now I'll go to work examples. All right, I've included this information here, which illustrates which of the 4 formulas that has been used in this work example. So we will start with the first formula, which is power is equal to work divided by time. All right. So if the question asks you, an engine does 60,000 joules of work in 10 minutes, determine the power. So the answer will be power is equal to work done divided by time. And you must remember what we mentioned just now, that all the units must be in SI units. So this time T must be in seconds, and work done must be in joules. So your work done is 60,000 joules. Your time converted to seconds is 600 seconds. So you get a power of 100 watts. Okay. So next question. A kettle is rated at 1850 watts. Determine the maximum amount of thermal energy it can generate in 1 hour. So this question is not asking you for power. Instead, it's giving you the information about the power and the time. So they want you to find the work done. So if you rearrange the formula, you will realize that the energy is actually equal to the power multiplied by the time, because you are going to cross multiply this over here. All right. So the answer will be 1850 multiplied by 3600 to give you 6.66 times 10 to the power 6 joules of energy. All right. So let's move on. The next one, what's the difference between the performance of a Porsche and a Nissan? The Porsche is rated at 320 horsepower and the Nissan is rated at 107 horsepower. A horsepower conversion between horsepower and actual power is 746. Alright, so that means 1 horsepower is equivalent to 746 watts. If you do the conversion properly, the Porsche will have a power of 239 kilowatt, while a Nissan has a power of 80 kilowatt. Alright, now the Marshall Cavendish answer next is that the Porsche will convert fuel more efficiently compared to the Nissan. This is only one possible answer, because this is provided that the Porsche and the Nissan has the same amount of same size of a petrol tank. Okay, if let's say the Porsche has a much larger petrol tank, it doesn't mean that it is more efficient. It just means that it converts more petrol per second. All right. So anyway, let's take this as the answer. If let's say they have the same petrol tank, the same volume, then the Porsche will be a more efficient energy converter, and probably due to a better design of the engine. All right. So let's move on. The next question is a question that adds efficiency. Now, what happens if the efficiency is not 100%? So in this case, electric motor in the washing machine is rated at 1 kilowatt, and the efficiency of the motor is only 40%. So find the amount of energy that is produced in half an hour. So we must remember what is the formula of efficiency. Efficiency is actually the percentage of the energy that is converted to useful energy. So if I want to write down in a very simple way, the input energy, I hope that I'm not going to overwrite any of the things that is going to be flashed, is equal to the useful energy. Okay, just let me do short form, don't write the word energy, and the wasted energy, right? So the input energy will become the output energy. One of them will be the useful energy, the other one will be the wasted energy. So if the efficiency is only 40%, that means that if the input energy, which is always 100%, okay, its useful energy output is only 40%, and the wasted energy is 60%. So to answer this question, you simply have to first find the total input energy, and the total input energy will simply be power times time. Again, you need to convert to seconds. So 1 kilowatt also need to convert to watts. So 1000 watts multiplied by 30 times 60 seconds, which will give you 1.8 times 10 to the power 6 joules. Alright, so if you want to find the useful energy converted, you simply find 40% of this value. So the answer will be simply 7.6 times 10 to the power 5 joules. Alright, this will be your answer. Okay, sorry, it overlapped here. Okay, now from this point onwards, the slides will be additional questions. Alright, so you need to copy on a fresh sheet of paper or at the back of your slides. So now this example is using power equal to force times distance divided by time. Okay, if you are given a 5 kg load that is lifted up a height of 20 meters in 10 seconds, what is the average power delivered? So you must remember that the minimum force required to lift a 5 kg load is exactly equal to its weight. That means that if this is 5 kg, its weight is 50 Newton. So the minimum minimum force to lift this will be exactly equal to 50 Newton. Alright, so first of all, we use the formula power equal to force times distance over time. Why do we use force times distance? Because you need to do work against the weight, so you need to apply a force. That's why you have to use this formula: force times distance over time. So because, as I mentioned, the minimum force required is 50 Newton, so and then the distance moved in the direction of the force is 20 meters, you get the work done by the force. Then after that, we divide it by 10 seconds, you get your answer, which is 100 watts. Right, so this is your answer using this formula. Okay, F times D over T. Next, the next example is an example using this formula: P equal to energy change divided by time. So when do we use energy change? And what do I mean by energy change? Energy change divided by times refer to how much energy an object gains or lose. But it should be the same type of energy. For example, it can gain kinetic energy. So that means that the E in the ET represents energy change, Alright. So in this question, it says that a meteorite of mass 100 kg accelerates as it enters the Earth's atmosphere and increases in speed from 1,000 meters per second to 5,000 meters per second in 20 seconds. What's the average power delivered to increase its speed? So there is an increase in kinetic energy because the speed increase. So because there's an increase in kinetic energy, that means that there is a energy change. There's a gain in Ke. So that's why we use this formula, P equal to E over T. Alright, so you'll get half times 100 times 5,000 square minus half times 100 times 1,000 square, divide the whole thing by 20. So if you work out the answer, it should be 6 times 10 to the power of 7 watts. Alright, so that is when you apply P equal to E over T. Okay, now the last one. When do you apply power equal to force times velocity? Okay, you apply power equal to force times velocity if the velocity of the average velocity of the car is given, or the object is given, and the force applied is given. Like for example, in this question, a car of mass 1,500 kg developed an engine thrust of 500 Newton to push the car forward. If the car is moving at an average velocity of 10 meters per second, what is the average power delivered? Alright, so the solution will be power equal to force times velocity. And you realize that when you use this formula, there's always a lot of distractors, because in the question usually there will be more information like the mass of the car, but you realize you don't need the mass of the car to find the answer. So be careful. This information about the mass is not important. So the power will be simply equal to 500 times 10, which gives you 5,000 watts. Alright, so that's how you find the power using F times V. Okay, so this is a summary of the chapter. I suggest that you can read this, or you can create your own concept map, which is even better. You should by now have the habit of creating your own concept map. To remember that concept map, definition, and formulas and application are all very important in physics. So with this, that's the end of the lesson. I hope that you will do the practice question and also the worksheet, and then we'll go through it after the holidays. Thank you and have a nice day.